Okay, so here I'm going to work through the problems. I do advise you have a look at the first one and then follow it along. And then you can try the successive ones and check either against the mark scheme at the end. But if you're stuck, these are some solutions to these problems. So, question one. We have two balls on bowling green. Ball A is moving at a velocity of 4 meters per second. Both balls have a mass of 1.5 kilograms. So, calculate the momentum of the ball before the collision. So I'm using the equation momentum equals mass times velocity. So I've got a mass of 1.5 times 4 equals 6. So I've got 6 kilogram meters per second. What is the total momentum of the balls after the collision? Well, I've got nothing from B, so only from A, so it's going to be the same answer. It's 6 because B has a momentum of 0. Calculate the momentum of the ball A just after the collision. So I have to look back up. After the collision, the ball is moving, A is moving with 1 meter per second. So the momentum of A is going to equal, mass is 1.5, this times 1, so I've got 1.5 kilogram meters per second. Calculate the momentum of ball B just after the collision. Momentum is conserved. So what I know is that 6 has got to equal the momentum of A plus the momentum of B, as A is, so 6, so 1.5 plus the momentum of B. And hopefully from that it's clear that therefore B is 4.5 kilogram meters per second. Calculate the velocity of ball B just after the collision. Just checking, both balls have a mass of 1.5 kilograms. That's fine. So I will have 4.5 equals a mass of 1.5 times V, and do that division, and I'm going to get 3 meters per second. Phenomenal. Calculate the loss of kinetic energy in the collision. This is an interesting one. So my kinetic energy at the start is equal to a half mv squared, and that's all coming from ball A because ball B is not moving. Okay, so what that means is I've got a half times 1.5 times 4 squared, 0.5 times 1.5, and I've got 12 joules. So that's what I've got beforehand. Now, afterwards, I've got some kinetic energy of A, I've got some kinetic energy of B. So afterwards, the kinetic energy of ball A, I seem to have changed colour, but I'm going to just roll with that. It's going to be exciting. Or at least I would if this would write. Right, why not? Oh, it's because it's turned off. The kinetic energy of ball A is, just got to check my masses, so 1.5 and 1.5 and 1. So I've got kinetic energy is half times 1.5 times 1 squared. 0.5 times 1.5 times 1 times 1. I don't know why I'm doing this into the calculator because I know that's 0.75. 0.75 joules. The kinetic energy of B is equal to a half times 1.5 times 3 squared. So I've got 1.5 times 0.5 times 9, and I've got 6.75. Add them together, and I've got 7.5. Now, the loss is therefore 12 minus 7.5, and I've got 4.5. So I've lost 4.5 joules of energy. And that, you notice, whenever two things collide, they make a kind of a clunk sound. So you're losing energy in that sort of collision. That's how we answer question 1. Question 2. Use the correct answer. Velocity is a speed in a given direction. Come complete the table. Which are scalars, which are vectors? Acceleration, you accelerate in a particular direction, so it's a vector. Distance, that is a scalar. Force, that is definitely a vector. Time, that is a scalar. Supermarket trolley is moving in the same direction. We've got trolley A, mass of 8 kilograms, moving a velocity of 2 with a kinetic energy of 16 joules. Trolley B, empty, mass of 4, moving at 0.5. So momentum of both trolley A and trolley B. So momentum of A is 8 times 2, so that is 16 kilogram meters per second. Trolley B is 4 times 0.5, so that is 2 kilogram meters per second. I've done my unit there. The trolleys collide, join together, they move off together, calculate the velocity with which they move off together. So I've got the initial momentum is 16 plus 2, so I've got 18 kilogram meters per second, which is therefore going to equal the final momentum. So if we solve that problem, they're moving off together, so I've got to add their masses, so I'm going to get a mass of 8 plus 4, so I've got a mass of 12. Essentially, they've just moved off together. So equals mass times their velocity. So I've got 18 is equal to 12 times the velocity. So I've got 18 over 12 equals the velocity. So 1.5. A different situation. The trolleys in the diagram move at the same speeds as before, but now move towards each other. Calculate the total momentum and the total kinetic energy of the two trolleys before they collide. And this is about remembering that momentum is a vector, but energy is not a vector. So the total momentum, this time beforehand, I have, instead of having 16 and 2 both going in the same direction, I will have, say, 16 going that way, and I've got 2 going that way, so they sort of cancel out. So my total momentum beforehand is 14 kilogram meters per second. However, the kinetic energy, that's a scalar, that's unchanged. Okay, they're both, you don't have energy in a particular direction, so I still have the same kinetic energy. Tell me the original kinetic energy. Yes, kinetic energy of 16, 0.5. So that will just be 16 plus 0.5. So it's 16.5 joules. Right. Number 3, paintball gun. What is the momentum of the paintball gun before it's fired? Well, it's 0, because it's inside the gun. It is not moving. V equals 0. The gun fires the paintball forwards. Paintball has a mass of, so momentum P equals M times V. So 0.00030 times 90, and we get 0.027. The momentum of the gun is conserved, so the total momentum of the paintball and gun after it gets fired will be equal to. The mass of the paintball gun is 1.8 kilograms. At what velocity does it recoil? So what we will have is, so we need the momentum of that in order to be 0. The momentum of the ball going one way will be equal to the momentum of the gun going the other. So we get 0.027 is equal to mass times velocity, or let's be fair, it's minus because it's a negative momentum. If we said forwards is going one way, this is going backwards. So we've got velocity equals minus 0.027 over 1.8. So you've got 0.015 meters per second negative. So the negative just saying it's going the other way to the paintball. The figure below shows a skateboarder jumping off forwards on his skateboard. So we're going to be saying, okay, what is it that we're looking for? Oh no, it's why does the skateboard move backwards? Well, your key point is that the first thing is that is to make some, is that momentum is conserved. Your second point, therefore, is that initial momentum is 0. And if the initial momentum is 0, that means that so skateboard must have equal and opposite momentum to the child who jumps off it. So those are the three sort of points for things. We've got a mass of a skateboard, mass of a skateboarder. Calculate the velocity at which the skateboard moves backwards. The skateboard jumps forwards with a velocity of 0.3 meters per second. And they've given our direction as being backwards, so we don't need to worry too much about the pluses and minuses because we've already been told it's going backwards. So it's kind of encompassed within the words. But what we end up with is our skateboarder is going to get a momentum of 42 times 0.3 is going to be equal to 1.8 times the velocity of the skateboard. So that, if we rearrange that a little bit, so because that's mass times velocity equals mass times velocity, skateboard, board. So 42 times 0.3 over 1.8. And we get a lovely number. 7 meters per second. So backwards. Right, okay. What is meant by momentum is conserved? Well, that means that momentum initial equals final momentum. Momentum may not always be conserved. Why? That means that there is an outside force. So that could be friction, or drag. Oh, that's an interesting line. So something else is acting on it, which is removing momentum from the system. Now remember, that's why on the air track I had to have no friction acting, otherwise things would just stop anyway. Calculate the change in the momentum of the car. So we've got the change in momentum of the car. Okay, so I'm looking at that compared to that. So the initial momentum of the car is 1200 times 10. Okay, that's nice and easy. 12,000 kilogram meters per second. the final momentum of the car is same mass, so 1200 times 2, which is 2400 kilogram meters per second. The change in momentum is the difference between those two things. So I've got 9,600 kilogram meters per second. So use the idea of conservation momentum to calculate the velocity of the van when it's pushed forward by the collision. So if my car loses 9,600, that must mean the van gains 9,600. Okay, so that's the van now has a momentum of 9,600. So I'm using P equals mv, so the little subscript V for the van. So I've got 9,600 is equal to, what was the mass of the van, is 3,200. Oh, I've changed colour again. 3,200 times its speed, velocity. So I don't know why I've done that. That's easy. That is, so V is equal to 3 meters per second. Oh, look, they've given us the direction forwards. You can see even exam questions are not always consistent in whether or not they're adding the statement of direction. But question 6. Haha, we're nearly there. Smiley face time. Oh, that looks pretty angry face, actually, to be very honest. Right, okay, so why do the teenagers not have the same direction? Momentum, I've just answered. They are moving in different directions. Okay. One of the skateboards, hopefully we're getting familiar with this, so slows down and stops. Teenager jumps off the skateboard, causing a recoil, moving in the opposite direction. What is momentum? Conventional, so initial momentum equals final momentum. At this point, you can probably start to see why, after a long period of time, people just start using P, and symbols for things, because you just start writing things out forever. Calculated mass. That's exciting. Same thing, but different. So the teenager of mass 55 kilograms jumps off at a certain speed, causing the skateboard to recoil at 10 meters per second. Calculate the mass of the skateboard. So what we can say is that the momentum of the teenager, which we're going to get with that one and that one, in one direction will equal the momentum in the other direction. So we're going to say 55 times 0.4 is equal to the mass of the skateboard times 10. 55.24 is 22. So we've got 22 equals m times 10. So divide through by 10 and we get mass equals 2.2 kilograms. Once the skateboard starts to recoil, it soon slows down and loses its kinetic energy. So we've got friction will convert Ke to thermal, or heat loss via heating, or via heating, so lose energy via heating. So yeah. Number 7. So define momentum. Is another one. Whenever they say define momentum in physics, it's really just saying what's the equation. So it's the product of mass times velocity. We've got a wonderful situation here. It's quite long. Bullet being fired into a block of wood, suspended by a long thread. Bullet stops in the wooden block, and the impact of the bullet makes the block swing. Velocity of the wooden block can be calculated from the distance it swings. In one such experiment, a block of wood and bullet have a velocity of 2 meters per second after the impact. The mass of the bullet is 20 grams, and the mass of the wooden block is 3.980 kilograms. Remember that obviously one's in grams, one's in kilograms. It's quite nice because 20 grams out of that just makes 4 kilograms, which is exciting. Which is the first question. Oh, okay. So it is 4 kilograms. Calculate the momentum immediately after the impact. So I've got momentum is equal to mass, which is 4, times velocity, which is 2, 8 kilogram meters per second. State the momentum of the bullet immediately before the impact. It's going to have to be the same number because it's the only thing that's moving. Calculate the velocity of the bullet before the impact. Right. Okay, so I've got momentum equals mass times velocity. So that gives us 8 equals mass. So 20 over 1,000, because I've got to convert it into kilograms, is 0.02. That's 20 grams in kilograms times the velocity. So I've got 8 of that, and I get 400. Yeah. If you don't convert, you're going to end up with a very, very, very tiny number. Yeah. Calculate the kinetic energy of the wooden block and bullet immediately after the impact. So I've got kinetic energy equals a half mv squared. So I can say, right, okay, so I've got a half times 4 times 2 squared, I believe is what I've got. Yeah, half times 4 times 2 squared, so it's 2 times 2 times 2. So I've got 8 joules, which is a nice number. The kinetic energy of the bullet was 1,600 joules, which is that's a lot of joules. What has happened to the rest of the energy? So that has gone to that's been lost. Ooh, no, lost via heating. So it's a lot of energy is lost. 1,592 joules of energy has been lost via heat, or by deforming the bullet and pushing the wood out of the way. So that's how we solve those problems. So I hope that helps make those clear, if there's any of those that you were struggling with. Thanks, Sage. Smiley face.